Okay, we've got the microphone. Is everybody in? We are going to fly through this presentation for two reasons. It's an hour presentation split in half an hour. So I'm going to speak twice as fast to make up for the time. And second, we're late. And third, I had my sleep, so my energy levels are back. Way! Exciting. So this is the HTTP 101 divided by 2. So we're going to go to from 0 to 50 in 30 minutes, or at least we'll try. So for this presentation, I'll ask you to keep your questions to the end and probably ask them, come and see me after the talk in the coffee area rather than at the end, so we can get back on our schedule. So HTTP caching is the thing that we completely ignore when we start web development. Sorry about that. We completely ignore HTTP caching because most of us don't understand it very well. And there's very good reasons for that. It's a very, very confusing set of technologies with very strange names, as we'll see, that very rarely define correctly what we're trying to do. Typically, you build your first web application as a new web developer. You're very young, very excitable, and you build your dynamic content using ASP, PHP, or Perl if you're an old-timer. And you realize that suddenly things start breaking when you deploy a new version or when you test a new version. Why? Because you get the old version of the document instead of the new one. So you've got JavaScript code that's not in sync with your CSS, which is not in sync with your HTML application. At that point, you go online, you try to find what the hell is going on, and then you copy the meta tag that I see still in a lot of production applications today that disables the whole of HTTP caching. Or at least tries, because as we'll see, most of those copied and pasted instructions don't work because they're not written the correct way. So HTTP caching is there so we can cache documents. It's a nice way of scaling, because every single time I cache at a step along the way to my server doesn't have to reply. And of course, the communication goes quicker when it doesn't happen at all. So we try to cache in various places, and for that we've got multiple caches. I am going to fall on this thing, so I'm going to move this over there quickly. There we go. There, and that way I may survive the presentation without breaking my foot again. We have plenty of different caches along the way. The first one, so this is the internet without caching. This is the ideal solution where nothing is cached anywhere. You've put your instructions to remove caching everywhere, and the world is good. Especially as you can see, we've got a lot of diversity on the client side. Oh, it's a conference, so it has to look cool, right? So the first step, of course, is the browser cache, or the temporary internet file if you're using an outdated browser. We have this on all browsers implement it, and all browsers implement it slightly differently, which is interesting. Most browsers implement most of it correctly, and then some edge case scenarios don't work. And then all the versions of Internet Explorer until version 10 do it mostly wrong. Mostly wrong is not exactly true. They take the liberty to not follow the spec in a repeatable way. We'll see one example later, maybe, if we have time. So that's one kind of cache that we all kind of know. But there's plenty of other caches on the internet. We've got the firewall, not this one. That's a horrible movie. There you go, that's better. Nice pixelated office clip arts. If anyone from Microsoft is watching, it is really time for us to get new clip arts. The proxies. Why do I say the proxies? Because in the enterprise environment, we have a lot of those babies that happen to be chained together. Now, they are not managed by developers. You probably don't even know the people that manage those servers, probably because they hid away all the network administrators in a bunker so that there would be no fights with developers. And the other way around too. So there is also a solid firewall between them and us. Those infrastructures, when you talk about global customers, are huge and cost an absolute fortune. Now, you all know this kind of stuff through the term WebSense. I'm sure some of you know that. Or the, oh my God, this blog engine has been blocked as containing adult material this morning. What to do? Those are the responsibility of those servers. The caching infrastructure in a big company is usually a whole bunch of servers that are all dispatched in various locations around the world in each of the offices, and they all communicate together. And you don't really have very much view of what happens there, except to know that it exists and sometimes pops up when content gets blocked. Well, all these tend to not be used by us. We very rarely understand ISA server as a way to cache our own application data, which is a shame, because then what we end up doing, and again, those big companies, is rebuilding the whole of the caching infrastructure that's already in place at the application level. We'll cache data on a specific message-based DHT somewhere. We are building twice the same infrastructure that does exactly the same thing. So these things exist. We'll see that if we understand caching, we can start leveraging them instead of us having to deploy the servers and pay for them, which is important considering budgets are being cut everywhere. That's not all, though. We also have reverse proxies, another different kind of cache. The fish here, for those of you that don't eat fish, there's a lovely double entendre in English that I'm sure is lost on most of you. Is a squid. The squid, because one of the main reverse proxies that we can install in the enterprise is called Squid. We use reverse proxies to pretend that the reverse proxy is our server. So this little guy here is going to live inside your company, in front of your servers. It's going to see if it's got a cached response already, and it's going to reply if it has something that is still valid. If it doesn't, then it will go to your server. So if you have data that doesn't change very often, instead of regenerating dynamically everything, or worse, using application level caching, such as ASP.NET caching, we can just put a bunch of very cheap servers at the front that are going to take away a lot of the load. And those babies cost very little money because you don't need good hardware on it, because it's only a cache. If it fails, that's not a big deal. You still have the data behind it, so the server can still handle it. So we can do those deployments much more cost efficiently. There's also translating proxies. This is from Hitchhiker's Guide to the Galaxy. It's Babelfish, apparently, according to Google Images. That's Babelfish. So Babelfish, why? Because we have those proxies working for us to translate from one format to the other, or to translate on the fly certain formats. How many of you use tethering on these, connecting your PC to access the internet from this? Right, half of you. Majority of mobile operators run those translating proxies for you. Why? Because on a mobile connection, they want to reduce the amount of data they send on the wire to you, mostly because they promise you broadband, but they only have enough to provide you with much less data than that. So they try to optimize as much as they can using certain commercial products. And they're going to take your nicely crafted HTML page, JavaScript, and CSS, compress it, remove the white space, sometimes even include the JavaScript inside your page, and send it down the 3G connection to your laptop. The HTML you get on your browser is completely different from the one you wrote. I learned that by accident when I was trying to diagnose a client problem on a website, looked at the view source and went, I've got someone hacking in my servers, it's not my HTML. Then I did my research and realized that I should probably use a real internet connection to do my debugging. So we have all those proxies, and they are going to cache the data in many different ways. Now, what is the default caching policy that is acceptable? If I say nothing about caching, is a document cacheable according to HTTP, according to what we use on a day-to-day basis. Who thinks that you can't cache by default? Because it would be crazy. Who thinks that you can cache by default whichever way you want? Okay, in both cases, I've got no hands risen. Who doesn't understand the question? The default is you can cache whatever you want, whenever you want, for however long you want. There is absolutely no restriction. This is why the first time you try to build a dynamic application, it starts getting cached all over the place. There is nothing that prevents you from caching data. Actually, we couldn't prevent that. If the guys that have the mobile phone companies decide to cache your HTML pages for however long they want, you have absolutely no control over that. So the specification leaves it completely up to the different caches to do what they want with the content, and even specifically says that by default you can cache stuff. Very counterintuitive. Or it was for me. Now, by default, that means that we don't exactly know how things are cached. The caches are going to use certain heuristics. Now, heuristics is the word in IT that we use for we're not sure how the algorithm works. Right? And what happens when you don't exactly know how the algorithm works is that you may stumble upon things you didn't expect. I'm going to demo this to you now, and I hope no one will be offended at either browser vendors. There you go. Bing. Let's type heuristics. That's interesting. So, plenty of lovely images that you can use for slides. Some of them that you can't use for slides if you want to continue being a presenter for very long. But maybe it's just a Bing problem. So let's go to Google Images. I just think it's hilarious. Heuristics. This is live, by the way. I'm not inventing this stuff, right? It's just anyway, I personally would prefer if both genders were represented there. Actually, I would much prefer with just one gender being represented. But there you go. This is heuristics. You end up with unintended consequences or unintended results that are not always the ones you are wishing to have. So we can start providing more information to the system so that we may potentially go back to a more repeatable experience with no surprises. One of them, need to refocus on this. One of them is the last modified header. Last modified is going to say when the document, the resource, the thing behind the URL was modified last. Why would we use that? Because it gives enough information for a cache to assume how long things can be cached. So this is a typical HTTP request. For those lucky of you that have never looked at an HTTP request, it starts with a GET, which is called a method. The method instructs the server what you want to do. Here I want to get the content, followed by the URI. Some of you may call that verbs if you use frameworks that use the terms we used in the early 90s. I tend to try to use what HTTP has been calling it since 96. The response is on the bottom. This is where the little arrow goes in a different direction. And we've got a status code, which is the way in HTTP to tell the world what happened. 200 means everything went fine. It's cool. And then the OK is just a string that you can put in there to help people that access the internet through a telnet remote endpoint understand what happened. It's actually borderline true because NNTP used to do that. Anyway, we are going away from HTTP there. So I can put the last modified, and this is the format of my last modified date. I would advise you to look at this format very well, because if you ever modify the last modified yourself, chances are in 90% of the cases, you're going to get it wrong. There's only one format for HTTP dates, and it's that one. And you see at the end is GMT. Only GMT time exists. Now we are in GMT+1 here. if you just do a datetime.now.toString, you're going to end up with GMT+1. And there's a lot of HTTP traffic that goes over the internet with completely invalid last modified dates. So please try to generate the correct HTTP date. Why was I saying that it gives more information for caching to do the right thing? It's because the older a document is, it's a bit like your parents. The older they get, the least probable it is that they'll ever change. Right? So a very old document can be kept cached longer because it's unlikely to change. A very new document is probably still being worked on. It's a bit like IT project. Completely unlike marriage. So this is one of the optimization we can do. You see, there's a mix and match of different things that you can do. It's just a few things that you should focus on when you start dealing with HTTP caching. If I did the whole thing in my REST training course, we spent a whole day on caching. So this is really condensed. Conditional requests are an optimization techniques. Right now we said here's enough information for the cache to cache the information properly. Why do we want it to be cached? So that our end server doesn't get called. Conditional requests are a feature of HTTP which lets us not retrieve the content again if it's already been cached, be it on the browser or in the other intermediaries that we've seen earlier. A conditional request is going to look like this. I'm still going to have my get with the URL going to the file, my presentation. Wonderful file, they should all download. And we add the if modified since header. As its name indicates, it says, please only give me this document if it has changed since the last time I looked at it. If it has not changed, then we just return a 304. And that 304 means we don't have to re-download the content. Now, all this stuff, when you expose a file over IIS, is done for you. If you generate dynamic content yourself, then you may have to implement this yourself. The next step is to get more control over when things expire. And this becomes very, very confusing the more we go into it. So we're going to try and take it as slowly as we can do, given the time we have. Explicit expiration is going to let us tell the system when the document is not up to date anymore. As I said before, the system, when you give it last modified, assumes, and the system is the internet, the tubes, the lolcat provider, is telling the system when it was last modified, and then the server make heuristics based on the age. With explicit expiration, we are telling the system that in 60 seconds, this message will auto-destruct. Wonderful show. The more I go through my professional life, the more I realize that some people I talk to never saw that show. So I'm sure you saw the Tom Cruise movies. I much prefer the traditional one. This is what an expiration looks like in HTTP 1.1. And we use the cache control HTTP header. The cache control HTTP header is what we're going to be able to give from the server to the clients, the intermediaries, the proxies, the reverse proxies, the translating proxies, and all the other bits and bobs in between to provide more information about what we want the system to do with caching. So here we provide max age 60 seconds. In 60 seconds, this document will not be up to date. Now, it doesn't mean, and I know it's surprising, it doesn't mean that the system cannot continue giving you that document after 60 seconds. It doesn't mean the document will auto-destruct. It will just say, in 60 seconds, it will just not be usable anymore. It will not be up to date anymore. So, to understand what the max age means, we need to understand the freshness model of HTTP. That's very important for everything about HTTP caching. The freshness model is the way HTTP describes when a document is up to date or not. And when I say document, please understand anything behind the URI is an individual document. A document starts its life fresh, clean, cute. It's up to date. It's the first time you get the document. It's fresh out of the oven. And then things are going to start caching it along the way. And for a while, that document is going to be still usable, but it will not be the fresh one because a proxy gave it to you, for example. So if you arrive at on Facebook in the morning at work, which everybody does for the first 2 hours, you know that the JavaScript that comes from your in your browser will not be served by Facebook most of the time. It will be served by the proxies in your company, because chances are your boss arrived at 8 o'clock in the morning, an hour before you, and went on Facebook for his first 2 hours. So by the point you arrive, all the JavaScript is already there in place so that Facebook doesn't have to resend that data. At that point, we call that data fresh. It is not from the origin server, it's not from the Facebook guys. It is not expired. What happens when we expire content? It becomes stale. At that point, if you receive that, well, first it usually doesn't smell very nice, but if you keep it a little bit longer, it starts smelling of Roquefort, which is, as a Frenchman, a nice thing. It's not from the origin server, it's not fresh anymore. That's very important to understand. Just because data is stale doesn't mean it's not going to arrive stale in your browser, because it's allowed. And this is what it would look like when it's stale. It can be stale for many reasons, right? But your proxy can serve you and will serve you stale data. And you can see a whole bunch of HTTP headers down you there. Here, an intermediary somewhere along the way has served me my document that expired after 60 seconds with an age of 4,000 seconds, which I'm sure some math geek in the room has already calculated in minutes and hours and other time measurements as well. And you see another warning header that tells you, ooh, pay attention because that data is not exactly up to date. We've got a status code for the warning as well of 113. That means that the data is stale. This is allowed and this will happen. There is no magic wand that will make caching go away. So what we can try and do is make that freshness model work for us, as opposed to try to fight it, and understand how it functions by annotating our documents with more specific expiration policies. And we can do that using the following, and most of those are quite interesting, or the three of those that I'm going to talk about quickly, quite interesting. The first one is the no store caching instruction. So if you remember the max age header I showed you earlier, you add a comma and you do no store. No store doesn't mean do not store. It doesn't mean do not persist. It doesn't mean do not provide in the cache. The only thing it means is, by the way, please try to avoid to store it on solid drives. So keep it in memory as long as you, well, as short as you can, but try to not put it on a hard drive anywhere. What do you think we could use no store for? Sensitive data. Yes. You're telling a guy in the middle that you don't control, that is on a system that is not yours, somewhere in Venezuela, please don't take that secret information and store it. So please do not use no store thinking that it's going to prevent any system in the middle from caching it, or stealing the data, or storing it on CDs and replicating it so that 12-year-old hackers may try databases of hashed passwords against your system. This sensitive data is going to not be protected by that instruction. So, if we can't control the guys that are going to receive that instruction, why would we use that stuff? Well, we would use that stuff, for example, if you write your own system that intercepts HTTP requests and does its own caching, let's say in distributed hash table, because you don't want to use Squid or another system, or just because you want to rebuild and reinvent the wheel. A lot of people do that for a living. There's nothing wrong with having many wheels. In that case, you control the intermediary. In that specific case, your origin server is talking to another server you control. At that point, you can trust that that server is going to do the right thing, because you have tests that show that it's doing the right thing, and you will fire the guy that does it wrong. When security-sensitive data, you'd rather, because it can get into a PR nightmare. All right, so that's one. Must revalidate. Second one, very interesting, that one. Must revalidate doesn't mean that you need to always revalidate. What do I mean when I talk about revalidation? It's the conditional request we saw earlier. So when I'm going to want to provide a cached copy of my presentation, when am I going to go back to the origin server to check if something has changed? Now, if the data is fresh for a while, I may never go back there. If the data is stale very quickly, I may go back. Must revalidate is telling me that when the data is stale, I may revalidate. So I may serve data, I may not serve data from my own cache, I may have to go back to the server and check if something has changed. No cache. Very interesting. Actually, yeah, you'll see in the diagram. I've got a little diagram to explain that. No cache doesn't mean do not cache at all. That is not what no cache means at all. It means that you need to revalidate the content even if you have a fresh copy. It doesn't mean that it's not going to be on the cache server. It will be. When an HTTP proxy is going to read a no cache, it's going to understand, please store the document, and please do a conditional request back to the server every time someone is asking you for it. But if nothing has changed, please serve your own copy. All right? So the data will be cached. It just will ask you nicely from time to time, if it functions properly, if the document has changed. This is the little diagram that explains this a little bit more visible content. So you remember we've got a little baby. First, the fresh content and the stale content. If you put must revalidate, as long as the content is fresh, you will not be hit. Now that also applies to browsers. That also applies to Flash and Silverlight. Just because you put must revalidate in your response doesn't mean that Silverlight will go and ask you if the data has changed, as long as the data can be cached. Can the data be cached? As we saw before, by default it can. When we provide no cache, the conditional request happens even if the data in the cache is fresh. You will notice that at that stage, none of those states allow me to not cache anything and not have any proxy cache anything. So, how do we really want to disable caching? First, you shouldn't. The cache is a great infrastructure. Please try to use the cache whenever you can. Your users will love you for it. But if you really want to disable caching because you have a valid reason, so we can go as far as this. We set the max age at 0. That means that as soon as we receive the data, it's already stale. It's one of those nice surprises when you come from the supermarket and the fresh bread that you just bought is already all moldy. This is exactly it. And we also tell the system to not store it, just in case our internal systems tend to store stuff. And we're also going to tell the system to not cache. Now you're telling the system, data is stale as soon as you receive it. You need to always revalidate the data whenever you have a request. So you need to come back to me to ask me if things have changed all the time. And the no store, and by the way, if you can avoid saving it anywhere, that would be really cool. That's a good start for HTTP 1.1 clients. We need to add HTTP 1.0 expiration as well, because HTTP has had versions, and they tend to replicate information to ensure compatibility over time. So we need to tell the system a specific expiration date as well. Specific expiration dates. However, of you have seen expires -1. Seen that? It's even in knowledge bases at Microsoft. I've been fighting those people for a long time about that one. Sending emails, no one answers. It's annoying. Right. Expires doesn't take numbers. Ever. Alright? Don't use expires -1 because it gets standard geeks like me annoyed. Please don't annoy me. The spec says expires if it has invalid values. And there's two types of invalid values. -1 is one, and -1 is one, and GMT +1 is another. It means please do not cache. So by the way, if you mess up your date in the expires header, it means do not cache. It's already stale. And we provide the date because otherwise not all clocks of all the computers in the world are all synchronized at the same time. So we need both of those headers. And finally, we need a last one, which is kind of a weird header, which means pragma no cache, which in this case means do not cache. But it depends on which version of the spec you're looking at. So 1.0, do not cache. That's cool. Technically, the spec didn't say anything. The browsers implemented that. Then 1.1 doesn't say anything about that being caching. Kind of hints about it. And then 1.1 bis, which is a new spec being written, says, no, really, it is no cache. This time, we're not kidding. So you need that one as well for HTTP 1.0 clients, because we still have plenty of devices that are 1.0. Squid that I showed you earlier, reverse proxy, very well known, doesn't implement the whole of HTTP 1.1. It just uses part of 1.1 where it can downgrade to 1.0. It used to do that by default if you're running old versions. Tips and tricks, and we've got 4 minutes for them, which is perfect. Query strings. Do not use query strings if you want stuff to be cached, because things like ISA server, Internet Explorer, will not cache stuff that has query strings in them, however much you try to get the system to cache them. That's probably the fault of calling them query strings, as opposed to that thing you put at the end of the URI that we should never actually process ourselves. But they're there. If you use them, you're not going to be able to cache the data where you want, not in all the intermediaries. Now, in HTTP 1.1, it shouldn't matter. And some proxies do it, but ISA server still doesn't cache this stuff. How do you solve that problem? We could go into details, look at post redirect get, craft your URI based on the current query. That will give you more cache hits for that kind of systems. Display then request. That's a trick for those of you that have access to an HTTP stack, which even the browser has now. We can add the following cache control, only if cached. You can use that in the browser. You can even use that in .NET in a kind of weird, different, not quite that way, but it also works. The idea is this one. I want to know if my reference data that I had, my big list of data, has been downloaded before, because I have a trader. Traders have very little patience to wait for us to load data. So I need to click on the display list and it needs to go vroom. Now while it goes vroom, actually what I did was to go to the cache, get the cached version by putting that header in. If it's there, I display it right now. In parallel, I go back to the server saying, hey, have you got anything new for me? Hit me. The server comes back, gives me data. If it's new, then I put a little bar at the bottom saying, the data has been updated. Do you want to see the changes? I don't need to build caching in the clients. Do not build your own cache. It's crazy. It's crazy. There's only two complicated problems in computer sciences: naming things, cache invalidation, and errors off by one. So do not build your own cache. It's crazy. Try to use the browser cache when you can. When you use .NET, little secret, when you use .NET, you use the same cache as Internet Explorer. Always. You use WinINet cache. That has plenty of unintended consequences, but it does mean that if the browser has access to file before, when you use your .NET application, that cache value is still available for you to use. So try to leverage that one. We've got 1 minute left. Hash version and URIs. Try to increase the amount of time things are cached, because everybody will love you for it. If you have a script that changes, every time you deploy, give it a new file name. That way the old one can be cached forever. People that still need the old one will continue using it. People that want a new one will continue using the new one. You solve 2 problems in one go. You don't have to put expiration techniques in. You can just have 2 different files for 2 different versions. How to do it? Plenty of components exist to let you do that. Use CDNs. Stop shipping jQuery yourself. It's really annoying. Okay? Chances are jQuery has been downloaded, MooTools have been downloaded, all this stuff is already on your proxy infrastructure close to the user. Use the CDN versions whenever you can. I know it doesn't look good in the little Chrome performance thing at the bottom, but it looks good for your users because they don't have 2 megs of JavaScript to download before they can see anything. Know when to minimize and bundle. We've got 3 left, so I'll overrun by 3 minutes. Yes. Know when to minimize and bundle your files. As I said before, we have translating proxies on the internet for mobile devices. That means that some of your mobile devices will get optimized content without you doing anything. And it may actually fight you if you try to minimize and bundle the files. If you don't know what minimize and bundling is, I don't have the time to explain to you. Come and see me at the end of the talk and we'll chat about it. But if you do know what it is and you do your bundling yourself, do remember to use this caching instruction, the no transform one. This will tell the translating proxy, I do not want you to mess with my beautifully crafted, handcrafted HTML semantic plus RDF content. And it will prevent bugs, which is always good. Cache on SSL. Now, I know that most of you think that because it's secure, or TLS, same thing, because it's secure, even though it's not anymore, thanks Komodo, you can cache content on SSL. You just need to put a cache control instruction of public, and then the browser will put the data in the cache. So if you're serving your images and your JavaScript files over HTTPS alongside your website, make sure that you serve a public instruction for all files that you want to cache. The browser will put them in a cache the next time the user comes back. All this will come from the cache as opposed to be re-downloaded. If you're in the Canary Islands like I was last week and you try to access a website using an iPad in your hotel, the internet is horrible, I will thank you if you provide me with cached HTTPS content. Actually, I may actually be able to give you the money I try to give you to go somewhere without the whole system crashing because it tries to load a meg of data. And finally, if you really want to build your cache yourself, this is the flow diagram for HTTP 1.1 caching. Any application you build will get to that point of complexity. So help yourself, help the environment, help the system. Try to not build your own cache. Try to leverage the HTTP one. This is a bunch of links that are interested. I don't have the time to show you any of them. The first one is about HTTPS performance tuning. There's a whole bunch of interesting bits and bobs about caching over HTTPS. Second one, HTTP BIS. After 10 or 15 years of HTTP, we have a new version of the same thing that does the same. So we can expect to have HTTP 2.0 ready around 2045. HTTP Workbench is something I just put together very quickly to show how to use the local cache efficiently from .NET with all the options that exist in the caching, which are all counterintuitive and badly named. They must have taken a page from the HTTP guys to try and understand when data is going to be served stale or not. I don't have the time for demo, but you can go and download it from GitHub. It looks horrible. There's no test. It's hacked together, but hey, it's demoware. Finally, if you use OpenRasters, there is a caching component that provides some of the conditional constructs and the caching that you may want to use. Those details from me you already had. And I'd just like to show cool logos of open source projects that are much cooler than the competitors. There you go. Thank you very much. If we take questions, we'll take them over there or while you all go for coffee.